Alright, in this video we'll be continuing with the C# video tutorials. So we'll be going over your classes and multi-form objects. So far we've just been using one form so far. So we won't be using multi-form projects right away. We'll just be starting to talk about it. So here we have. So we'll start off with an intro to classes. So we've done. Did we do some of these in the notes? I think we did. Actually, no, we didn't. Okay. Maybe we should do that first. Okay, I'm already here, so let's just start with this. So, introduction to classes. So, a class is a blueprint for an object. It specifies the fields and methods a particular type of object has. So, from the class, one or more objects may be created. So, you can create multiple objects from one class. So, you think of the class as a blueprint that you use to create, for example, like multiple houses or something. So if you can pretend that house is an object and you can create many houses from one class. You'd have like house 1, house 2, house 3, house 4. All points to new house. If the class was house, then you could create more objects from house. So you could create as many objects as you want but you only need one class. So we've used some objects so far. We haven't really talked about them too much. I didn't like the way these docs were, like when I took this class, I didn't like how, well, because we already learned about objects in Java, so they don't really teach you about objects again. That's what I'm guessing. But pretty much, that's just the way it is. So if you're taking a computer science program at a university, they may just do object-oriented programming concepts once, and then kind of go into more of an advanced book for the second and third languages. I thought that book that I had on Java was bad. I forgot who it was by, but it was called Java Foundations. It was actually really good. It taught everything about objects really well. These books aren't that great. They're okay. By Tony Gaddies, I think, or Gladdies or Gaddies. He has a series of books on different languages, and I don't think this one is the greatest book, but it's not the worst book either. It's like kind of in the middle. So he also did the Python book. Once again, they're both in the middle, but it wasn't too bad. It was okay. They could have gone over classes and objects better. So anyway, so pretty much, so some objects, such as controls that you place on a form, are visual. So we've been using visual objects. For example, if we want to create a button points to new button, so we can do that here. We don't need to do that, but we've seen that before. If you've seen the playlist, creating a button object just references the class and it instantiates a button of type class, or button 1 of type class. So other objects. So for example, some controls. So some objects such as controls that you place on a form are visual. Other objects such as random objects, arrays, and list objects, and imageless controls cannot be seen on the screen but exist in memory and perform important tasks. So those are all objects. They don't really talk, like this book never really talked about this too much. They're just like, yeah, this is an array, and sometimes they're like, yeah, it's an array reference variable. They don't really say like, oh, you're instantiating an object here. That's what the other book did. So this guy didn't make it clear. That's why I didn't like this book as much. But it's not the worst book. It's just not the best book. It's around, I'd give it maybe a 5 or 6 out of 10. That was the reason, because when I was reading this book, I had trouble understanding myself, like what were objects and what were not. But I've tried to make that clear to the viewers. So if I go like button points to new button, I'm like, yeah, this is a button and it's an object reference variable. So anyways, that was a little confusing in these docs. Anyways, I'll try to make it more clear going forward. I think I have made it clear with most of the controls, so hopefully I did if you're watching the whole series. So we mentioned earlier that objects do not just magically appear on your program. So it has to be instantiated in memory and created in memory. So, and before an object can be created in memory, you must have a class for that object, besides structure objects and enum. I guess enum isn't really an object, but structure objects at least, you have to have a structure for that. So remember we talked about that you can create pretty much a structure object and a class object. So the docs recommend going for class objects if you want to use, create methods for structs as well. So a class is code that describes a particular type of object. It specifies the data that an object can hold. So an object has instance data such as fields and properties. And in C# it's a little bit different. So C# can have fields and properties. You can also have methods and stuff, I believe, as well. And the actions that an object can perform. So yeah, so methods. So you can think of a class as a code blueprint that can be used to create many types of that blueprint object. Okay, then there's the house example, which we already described. So a class is not an object, but a description of an object. So when a program is running, it can use a class to create in memory as many objects of a specific type as needed. Each object that is created from a class is called an instance of the class. So we've talked about this before. This is getting into a better description. I believe the Java Foundations book went over this right away and then started talking about arrays, and they're like, yeah, this is an object. That was better. I really recommend that book if you're going OOP. I forgot the name of it. I think it's Java Foundations 4th edition or 5th edition. They're both good. The 5th edition has a bit more JavaFX stuff in it rather than the old framework. I forgot the authors. It's two people. I really hated that book, but now I realize it was actually, when you go down later on, you're like, oh well, that book was actually really good compared to these other crappy books. But it was quite a well, actually it wasn't that long. Our professors made us read 1,400 pages in the last 14 to 1,500 pages in the last class I took. That book was like less than 500, but it was. I thought 5 chapters was a lot. Now they're testing us on like 20 chapters or more. But anyway, so pretty much, I'll try to get that name of the book if anyone's interested. It's really good for object-oriented programming. It'll take you into C++ and all that as well. Okay, so every time you need an object, you have to create it in memory. So that becomes so when you create an object, so each object that is created from a class is called an instance of a class, or you can just say an object of a class. Remember, instance means object. That'll take you far in programming. So let me I know I haven't been on the screen here, so let's just try to make some notes here. Back to the screen. So we'll just go, instance is a class. Oh, sorry, instance. Instance is an object. Or instance is a object, or an instance is an object, whatever. Of a class. A class is used to create objects. Well, it can be. It can be if you want to do it that way. Excuse me. So let's just say there's this person named Jessica, and she studies insects, and she also enjoys writing code, so she designs a code she designs an app to catalog different types of insects. As part of the program, she creates a class named insect, so we can just go with the insect like that. Classes are usually capital, so go with insect like that. Actually, not always, I can't remember. I think Java might make them capital. I'm just thinking, yeah, I'm pretty sure you make them capital, because when you create, for example, an array list, then you point it to new array list camel cased. So yeah, it's capital, so classes should be capital, I believe. So everything else like methods and stuff, I won't capitalize it, but Microsoft does, so it's up to you. Okay, so as part of the program she creates a class named insect with which specifies fields, properties, and methods for holding and manipulating app data to all types of insects. The insect class is not only an object, but a specification that objects may be created from. So she writes code to create a pretty much like bug objects, different kinds of bug objects. So for example, the ladybug object is an entity that occupies computer memory and stores data about a ladybug. It has fields, for example, like size, color, number of legs, or whatever. I don't know, like whatever it eats and random stuff. So are there green ladybugs or the yellow ones? It'll say like colors, whatever. So she writes statements that create for example, a moth object or a butterfly, whatever. So it would have the same fields and classes as the ladybug object, because you've created another object of the same class, which the class defines the methods and the fields and the properties that you want to use. So every object of the insect class would all have the same properties. Okay, so now let's actually get into some code here. So we have creating a class. You create a class by writing a class declaration. I believe you can also go public, private, it's up to you. Usually a class will be public, but not always. You might want to have a private class, or protected if you're using inheritance, which we'll talk about in the next chapter. Okay, so you could go class name. This is the general notation. And you just open a block like that. And here you put your fields, subclass members. So those are fields, methods, and I guess properties. And C# has properties. Fields are global variables. It's up to you what you want to call them. I believe C calls them fields. So this is the class header here, class name. It starts with the word class. This is a reserved word, class. You can also go like public or private, I believe. Public, you could have private. Protected, I think, as well. Excuse me. So it starts with the class. So it starts with the word class followed by the name of the class. The same rules for naming variables apply to naming classes. So most coders follow the convention of the class name with an uppercase letter, or having the class name with an uppercase letter. Then you open a block with a curly brace or bracket. Then you go with the declarations. So here let's create, for example, a class here. So we could do the coin toss class. So we need a coin class. Okay, so this is a bit of a code to do. I'm just thinking how to do it. Okay, so we'll do this in a sec. We'll just do it in the notes down here. So we'll just go here. We'll just go with class. We'll call it coin. Then here we'll just say private. We'll have a private field here, so private string side up. We'll call it side up. It's a string. Then here we'll have the constructor. So let's just have a comment here. This is a field. Or fields, go here. Then this is just the constructor which is used to set up the object. So to do that, you just reference the class name. So we go public, for example, coin. And here we'll just we'll just take side up and point it to the string heads in a string literal. And for example, we could have a method here called toss. Excuse me. So we could just go here with we could call public and then void, so we want the method to return void. So here we'll just call it toss. It'll take no parameters, and then we'll open a block. So here we'll say we'll create a local random object, so we'll say random points into random. Whoops. No parameters, semicolon, then we'll use a random number to determine the side of the coin that is facing up. So basically 0 is going to point to heads and 1 is going to point to tails. So if rand, so just making like a little game here. So then if rand.next passing in 2 points to 0, because remember it's always going to be 1 minus the parameter that you enter. So if you enter 2, it'll cycle from 0 to 1. So then we'll point that to 0. Then here we'll have, what else we have? So we'll go side up points to heads, because remember we said that if the value is 0, then we'll display heads on the coin. And then here we'll have, actually we'll go here else. So if it's not, remember if it's not going to be 0, it's going to be, what's the other only possible answer? It's going to be 1. So then we'll go side up, in that case points to tails, which is going to be 1. That's going to be the string tails. Here we'll close the string literal, add a semicolon. So that's the toss method. So underneath the toss method, we're still in the class block. You can see that. So we'll go with another method here. That's a string method. So returns. So the get side up method returns the value of the side up field. Okay, so we'll go with public string. So remember, in classes you usually have getters and setters. So getters can set your fields, setters can set them. So we'll go with private string here, and then we'll say get side up. So in that case, we're just going to return side up. So we can return side up here like this. Or I believe we could actually say return this dot side up because it's instance data, but we'll just go with side up for now. So that's pretty much it. So that's just the class. So you can pretend it's like a little game that we made here. So you can just flip a coin. It'll show you whether it's heads or tails, using a random number to show you what the flip was. So the first line is a class header. So we talked about that, and then we have, so that just tells you that the name of the class is coin. And pretty much it's all explained pretty well. So creating an object, so remember that a class is an object. Remember a class is not an object, but a description of an object. So the coin class specifies what a coin object is made of, but it does not create a coin object in memory. So to create a coin object, we must write a statement such as, for example, okay, so we could go under this. Okay, so this is a class. So usually you won't instantiate. I don't even think it's possible. It might be, but probably not, to instantiate a coin object within its own class. So usually you do this in like a main method or something. So you can just pretend that this is a main method. So here we'll go, for example, so we'll call it class name. We'll name it something. So we'll just call it, we'll go coin. For example, we could just go with like quarter, points to new, and then coin. So we're going to reference the class name at the beginning, name it, equal sign, then new, keyword, and then coin. Reference the class again. And then these are empty parameters, because you don't really need parameters to instantiate an object. So that's just it. Now if you want to say, if you want to call the toss method, you just go you just call the name. So you go quarter, and then you'll go dot, and then you'll access all the fields. So you have access to, you might not have access to this one because it's private, but since this one's public, you'll have access to toss. But if this was public here, if we had public string side up, then we could go here, we could go quarter dot side up points to. You could set it like that. But in this case, we could just go quarter dot toss like that. So since it doesn't take any parameters, we just include an empty set of parentheses. So far we've created different types of objects so far, mostly like graphical user interface objects such as like buttons, list boxes, labels, picture boxes, stuff like that. We've created random objects as well. We've created a few struct objects. So this instantiation is just the same as normal. So random objects, arrays. So arrays, we've created array objects, list objects. Those are all objects because you have to reference the class. So the first part of this statement in our instantiation of this coin object, appearing on the left side of the equals operator, reads so coin quarter. So this declares basically an object named quarter, which is an object of the coin class. We've already talked about this here. So we're instantiating a new instance of the coin class, or an object of the coin class. So we can perform operations on it, like I showed you how to call the dot operator to access its fields and methods. If you're accessing this object outside the coin class, I believe you'll only be able to access public methods and fields. If you're using inheritance, which we'll talk about coming up, if it's protected and it's a child of the class, then you can actually just reference any parent fields, but that won't make sense at this point. So pretty much you can just access public fields and methods outside the class. So private you won't be able to. So private helps you like secure things. So we could also show a message box here, so we could just say, for example, message box.show, and we could just say we want to show quarter dot. We could show get side up. We could show what the get side up method returns. So after we call the toss method, we could show what the side up is, and the side up returns a side up, which is a string. So side up could change at different times, so it just tells you the current status of side up as a string. So in that case, it's just going to show a message to the user. Okay, so where to write class declarations. In C# you have basically some flexibility in choosing where to write class declarations. When you start writing your own classes in a project, it is possible to write them in the same file that contains the forms class. I think that's as like an inner class. So we could show an example of that. Here in a sec. Actually, maybe we'll just talk about this now. So the Microsoft docs recommend writing the classes in its own file. That doesn't mean that you have to do that. Okay, so we can write this underneath the namespace. The namespace ends here, so we should be able to just open this here. we can comment this stuff out. Okay, I don't think public's gonna work. Sorry, no, wait a minute. Public doesn't work here. What did we say that this was? Let me just have a look. Okay, so we have, this was the void toss method. And it's supposed to be public, so public void toss. Oh, this is supposed to be closed like that. Closed, closed, closed. Okay, sorry, so let me just see what we have here. So we have our namespace. Okay, sorry, you have to write it within the namespace. That's my bad. Okay, so let's just copy this here. So we'll copy that, Control exit, and we'll go below this. So we'll go before the ending of the namespace. We'll paste that in there. So that should work. Okay, so underneath the namespace, then we have our partial class, your constructor. Close the partial class. Open the coin class. Close the coin class, and then close the namespace. Oh, whoops, okay, so we should say random here. Side up should be camel cased. That's going to be a good test question that your professor might ask you. They might go like, where can you put a inner class? And then you'll be like, okay, well, I'm going to put it within the namespace before the namespace ends or closes. Or within the namespace's ending bracket or something like that. But not outside, just make sure to specify. Okay, there's still something wrong with this. There's something, let me just read what the error is. Cannot use unsafe construct in safe construct on line 59. Okay, where's that? Oh, sorry to have this extra. There we go. So that's going to work and run. So we could show, where we print the message box. Okay, let's go with this. Messagebox.show quarter.get side up. See if that works. You may need an actual main method somewhere. We'll just try this though. No, can it not access quarter? Okay, I think you'd have to instantiate the object here, which would make sense. Okay, so we'll go with coin. Quarter points a new coin. Then we'll go with coin dot. Nope, sorry, quarter dot. Toss. Then messagebox dot show what the toss was. Dot get side up. You could always cast that to a string. Actually, it is a string. So we could do that. So we could say here. I think we can say this dot. So we could say this dot side up as well. Okay, first let's just try without it. Save it. Run it, and let's just see what happens here. This is pretty much exactly like Java. It's like almost 100% exactly the same. It's similar to C++, but there's a few extra symbols. Okay, so just other than that, here, just back to the code. It tells us that we have heads, so the side was heads, so it worked. So it tells you what coin was flipped. It tells you the status of the coin that was flipped. So here we could use a this keyword, so we could go, so this can return you basically field data or global data, instance data basically. So we can go this dot side up. So let me just maybe comment this out for a second, just go underneath here. You go this dot side up points to the string heads like that. So it tells me that this is redundant, but it's okay to use it because you may have another side up variable, like a local one. So that might help you as well if you want to try that. So here you could also just say this here. You could change all of them to this, anywhere that's it's referencing a global field or something like that. You just go like this as well. So if I run that now, I should have the same result and tell us what the coin toss was. Okay, so this time it was tails. So you won't see that, it was just an extra pop-up window. But if you are following along in the code and your IDE, you would have gotten either tails or heads. So that's pretty much it. In the next part of the series, we'll be going over more class declaration and stuff like that. So thanks for watching, guys. If you guys liked the video, you can like and subscribe to support the channel for more programming and investing tutorials. So hopefully I'll see you guys in the next one. Thanks for watching. Take care. Thanks.